Hello everyone and welcome to today's session, Exploratory Data Analysis. Today is a continuation of our Exploratory Data Analysis, that is EDA, and this is the third video, and we will be discussing Bivariate and Multivariate Analysis. So let's give the title EDA, that is Exploratory Data Analysis, and we'll be talking about bivariate and multivariate analysis. Previously, I have discussed with you that what is EDA, okay? And also in the last session, I've discussed with you what is univariate analysis and how you can do those. We used Seaborn and worked on Titanic dataset. Today we will also be using Titanic and also be using Seaborn. But first of all, what is bivariate and multivariate analysis? Well, suppose this is a data frame having the column A, B, C, and D. In univariate analysis, we used to work with single rows, right? Sorry, single columns. It might be this one, this one, this one, anyone we like. But in bivariate, the name itself suggests that we will be dealing with two columns. It might be these two, or these two, or these two. Any two columns. Okay? Similarly, in multivariate analysis, we will be doing analysis on 2+ columns. It might be these three, it might be these three, or it might be all of these rows. Okay? This is why it is multivariate analysis. So in simple terms, if it is two columns, then we call it bivariate. If it is 2+ columns, then it is multivariate analysis. Clear? Okay, fine. So as I mentioned earlier, that we will be using Seaborn. And if you look at the documentation of Seaborn, you will be seeing that there are different kinds of or categories of plots that we can build by using Seaborn, like distribution plots, categorical plots, it may be relational plots, or it can be matrix plots. Okay, you will find other types of plots as well, but these are the basics. If you don't understand, please go and look at Seaborn documentation and you will find all of these very well organized. Okay, so these are the main or the distribution, categorical, relational, or matrix plots that we are going to be discussing today. Clear? So there are lots of plots, but I also mentioned this one in the last session. There is a similar kind of syntax. And what is the syntax? The syntax is very simple. It is SNS dash something plot, and in bracket you have parameters. It can be data and x and everything else. Clear? The data, meaning the data frame, here we will be using Titanic, and there's going to be other parameters like every function has, right? X and others. And in this dash we will be using any plot that we like. It can be KDE, it can be count plot, it can be his plot, etc. So this is the basic syntax of writing a SNS, that is Seaborn code, or having or building a Seaborn plots. Okay. Here another note is that we use just X parameter in the univariate session. This is why it was called univariate. Uni meaning one variable analysis. Clear? Okay. So up until now, I've just discussed with you the basics or what we are gonna do today. So let's get to the main part, shall we? In any data frame, you have two types of columns. You have numerical columns and you have categorical columns. right? And this is why when you are doing analysis, you get three types of combinations. It can be numerical and numerical. It can be categorical column and categorical column. Or it might be numerical, categorical, or categorical numerical analysis. Clear? It's just three types of combination that we can have. Okay? We will be discussing all of the three broadly and seeing different kinds of plots to analyze and decide what the data set is actually telling us. Clear? Okay, fine. So first of all, we will be discussing bivariate analysis. Bivariate. So let's go to the notebook, shall we? Yeah. So first of all, it is the obvious stuffs that we have to import the necessary libraries. So let's run this. Yeah, we have imported pandas, numpy, and seaborn. We're going to be importing Titanic dataset by using seaborn. You know the code. Let's run it. Okay. If you want to see it, let me show you as well. df.head. We'll be seeing the first 5 rows. Let's run it. Yeah, you have the first 5 rows. And this code I also showed you in the last session. It basically separates the categorical columns and the numerical columns. Okay. Let's print it. Here you go, and it is listing out all the categorical and numerical columns for us. Okay, fine. So as I have mentioned, we will be doing three types of analysis, right? Three combination. So our first combination would be, let's say, numerical and numerical. Okay, fine. Now how can we do that? The first approach is very easy because we have discussed it in the previous session. You see this syntax? And here you see x. It is one parameter, right? But you also see these dots, meaning there are other parameters. And if you look at the docstring or documentations of any plot, you will see that there are other parameters as well. You will find y, you will find hue, and etc. So in bivariate analysis, we will be basically using another parameter along with x, and it becomes two parameters, and this is why we are calling it bivariate analysis. Clear? We're just gonna input a y value here. Okay, let's see that. Let's create a numerical plot. Let's create a histogram. Hist plot. The data is gonna be df, that is our Titanic data set. The x value is gonna be, let's say, what to take. Let's take age on the x-axis. Let's see the single one first. Okay, let me show you in this mode. Okay, let's zoom out a little bit. See this is a histogram that is for only the age column. It is age on the x-axis and count on the y-axis. It is telling us most of the values, most of the people are at the age in between 20 to 40, right? Yeah. Now as we are doing bivariate analysis, let's include another parameter or another column. If you want to see all the parameters, just do shift tab in Jupyter Notebook and it opens up the docstring having all the parameters there are. So much to do, right? You can customize, you can do lot of layouts, etc. Using all of these parameters. Okay, so it is very easy. Just have a look. So we have a y parameter or y-axis parameter here, so we can use that. Let's use that. Why? Which column to take? A numerical column. Let's take fair. Okay, let's run it. And here you go. It combined the two histograms and gave us a column. Gave us a plot. Okay, it is a combination of the two plots. This is why you're having this type of look. Okay, and here you see it is a bit deep. The color is a bit danced. Okay, a bit more blue, indicating that the most of the uh, uh, age is from 20 to 30, since the deep blue part is in the range 20 to 30 in age, and it is somewhere 0 to, it is almost close to 0. The fair part, it is almost close to 0, right? And here you can see only one fair is above 500, and it is almost at the age of 40. Someone who is almost at the age of 40 paid 500 plus fare in the Titanic trip. Clear? This is how we can analyze and make a decision. Okay, guys? Now, this is one plot. Let's do another plot, shall we? Let's do that. Let's build another plot here. Let's build another plot. Let's paste it. Which plot to make? A numerical plot. Let's build KDE. First of all, let's take one parameter for our convenience. Let's run. And you have a kernel density estimation plot. I have discussed broadly what this thing means in the previous two sessions. Okay, it basically suggesting us, the peak is suggesting us the number of population, the number of people. Okay, so the peak is in the range of 20 to 40, indicating the maximum people, the number of people are in this range, since the peak is the max here. Okay, and very few people are over 80, since it is almost touching the x-axis. Okay, fine. So let's do the bivariate analysis. Let's put a y parameter here, and let's take fair as our y-axis. Let's run it. See this? It's a weird plot, but how to analyze this one? The smaller the circle in the between, in the center, you see the smallest one, indicating the densest what to say, the densest part or correlation between age and fair. Okay, it is also suggesting us that between 20 to 40 most of the people are, and they are giving 0 to 50 fair. Okay, since it is dense in this range, so it doesn't look so easy, or it is not so appealing, but it is what it is. It is basically combining the two columns. Okay, but we do have a better option when we are dealing with numerical columns. Okay, and it is called scatter plots. It gives us a better view of the same thing. Let's do a scatter plot. Let's run it, and here you go. It is far more easier to analyze this one. As we can see in the very bottom, all the points are really dense, meaning this is the higher probability of having the correlation. Okay, most of the people are within the 20 to 40 range and having 0 to 30 fair. Okay, as we can see, only 2 points touching the 500 mark, and it is almost in the 40 mark, 40 age mark. Clear? And one person is above 80, only one person. Okay, so as we are saying all of the time that it is the fair is almost in between 0 to 50. Well, let's see the mode, what the maximum people gave. What is the maximum people gave, what amount of fair? We can see that by typing this code, that is, we can see the mode of the fair column. It is even less. Maximum people gave almost $8 in the Titanic trip. Okay, it is even less. Okay, the average is might be 30 due to we have some outliers. Yes, the average is almost 30 because of this one or two high value. It increased the average. Okay, it pulled the average higher, but most of the people gave the amount within $10. This is bivariate analysis, guys. Okay, now you might be wondering, like, it's too tough, it's too tough, you have to see the, how do I know? I might make mistakes in this decision, right? It would have been better if we had an exact number which showed the correlation. Well, the plots and graphs are meant to make your decision easy, to make you visualize stuffs. So it is a tool for us, but we can have a numerical value. How? Let's see that. The code for that is df dot wait df. We are gonna be correlating the H column with the fair column. Clear? Let's run this one, and as you can see, the answer is 0.096. 0.096. It is not so good. Okay, if it was 1, then it would be a perfect positive correlation. If it was -1, it would have been a perfect negative correlation, and if it was 0, this would have been, then there's no correlation. Now what do I mean? Let's see that. So what does correlation mean? Suppose there's A and there's B. If there is a connection that whenever A goes up, B also goes up, and whenever A goes down, B also goes down, then we call it a positive correlation. Okay, but if it is opposite, like when A goes up, B goes down, and when A goes down, B goes up, then we call it negative correlation. Simple? Okay. Now if it is 0, that means there's no correlation at all. No points are intersecting. Okay? So it is basically like we have an A and A. We can put an A, we can put this A over this way, A, and you will see that it is same. Whenever this is the case, it is called correlation +1, because it is overlapping perfectly. There's no indifference. Okay, and if it was this case, this is A and this is a rotated A, it is matching exactly oppositely, then it would mean a -1. Okay, now if it was an A and it was a big 0, then what would have that mean? There's no single point that is intersecting, no intersection, so it is going to be 0, meaning no correlation. I hope I'm clear. Okay, fine. So we saw the numerical correlation and bivariate analysis. If you see that, now we're going to discuss about the categorical part. Let's see that. So let's build a categorical count plot, shall we? Count plot. The data would be df and the x value is going to be a column. Which column to take? Let's say p class. It's a categorical column. Let's run this one. And here you go, your count plot. Okay. Now as we are doing the bivariate analysis, we need another parameter to make it two columns. So first let's see the docstring. Here we have a parameter and also a hue. Okay. The y, I think it's going to be giving me an error. Sometimes it doesn't go with one column. When it doesn't just go with it, it gives you an error. Like if I take which survived, let's see if that prints. It might give me an error. Okay, when it doesn't go. Okay, cannot pass values for both x and y, suggesting that these two columns, although they are categorical, but they can't get intersected and be presented, and it won't be a count plot anymore if they forcefully intersected. This is why it is giving me an error. But instead of y, you can have hue in count plot and you will have your answer. See this? Yeah. Now you can easily analyze that the class, first class, second class, third class, and also understand that what portion survived and which portion didn't. In the third class, class number 3, we saw most of the people died. Sad, really sad, really sad. Okay, the second class people and first class people, the death rate and the death number is almost equal, I guess, almost equal. Okay, so this is how you do the analysis, and you have bivariate analysis of categorical plots and categorical plots. Okay, we can also have a bar plot, the same thing, it will print the same thing, but let's see. It's called bar plot. Yeah. Okay, it is a bit different, it is a bit different. It is also suggesting us the total number of death and total number of survived, okay, in a way. So it is what it is, and this is the categorical and categorical part. There's not too much of categorical plots that you can do intersection with, okay, and you won't be needing it also. As I have mentioned in the numerical univariate analysis session, that in categorical column analysis, you basically see the lengths, you see the value counts. If you want to see that in pie chart, you can have it, but nothing else to see. Maybe null values, this is important. Okay, so there are not too much to explore in categorical columns, where in the numerical part there are lots of stuffs to see, like screwness, the outliers. There's also, you have duplicate values, not duplicates, the mean, median, modes, etc. So the numerical analysis is a bit important, more important, and it is a bit more hard work. Okay, okay. Now let's get to our third point, that is combination of the numerical and categorical plot. Here we are going to be building something called box plot. Okay, I think we can build the bar plot here as well. Let's see if we can build it. Box plot. Okay, sorry, bar plot, my mistake. bar plot. Let's say the x is p class and the y is fair. Okay, let's see what prints out. Yeah, here you go. So it's suggesting the first class fair is the highest. You see, we are having two different columns. One is categorical and one is numerical. And we are having the column very easily. The plot actually. Here you can easily see that the first class people paid the most amount of fare. Okay, the highest fare was from the first class people, then the second, then the third. Okay, in the combination of numerical and categorical, another very important plot to build is box plot. Okay, again, let's have fare. Uh, it's not gonna be hue, it's gonna be y. You can also see the doc string as well, x and y and hue. We're not gonna get to the hue part, we're gonna get to the hue part later. If it, I'll show you the both. Okay, let's show you the both. First of all with y and print it. Here you go, the box plot. Now what does box plot mean, which parameter it indicates? I've discussed all of the things broadly in the last session. If you have missed it, please do go to my YouTube channel and see that session. In the middle part of the session I have discussed it very broadly. Okay, still I'm gonna give you a reminder. Let's give you a reminder. Okay, I'm not gonna elaborate anything, just a quick reminder. So the box plot looks like this. You have a T here and a T down here. This is the third quartile or the 70% of the data. This is the first quartile or the 25% of the data. So the minus subtraction of these two indicate this box is basically the 50% of the data, which is also called IQR, that is interquartile range. There's a line in the plot also. This is called median, the 50% or the middle value of the entire y-axis. There's going to be a dotted line indicating mean or average of the whole column. Now if you see any value above here or down here further from T, these are called outliers. Okay, this thing you see, the T is basically the 1/5 times the IQR. This is ranging 1/5 of the IQR. Now if there is no outlier, then this point becomes the maximum and this point becomes the minimum of the total data that you have provided. And we are having a y-axis here. Okay, always remind, I'm not showing it, but there is a y-axis and x-axis. This will be quartile 3, this will be quartile 1. Okay, you're gonna be having value on the left side all the time. It can be x, etc. You get my point. The median would be just drag a line, this would be the median and this would be the mode, the mean. Clear? Okay. So as you can see in the first class we have a outlier here. It is single and it is really far away. We can also call these outliers, these are also very far away, but they can be managed, I guess. Here we also have some outliers. Here maximum value is ranging far away, but there are also one or two outliers. Not too much, maybe they can be managed. So this is the analysis. This is the analysis that we do. Okay. So guys, we covered the numerical, categorical, and also the combination of the both type of columns here. Fine. And here one also thing to mention that we use the previous plots, the previous plotting codes, and just inputted the y value, another parameter, to make it bivariate. We also use scatter plots in numerical part, and also showed you the correlation using correlation function of pandas to easily know the correlation between two or more columns. Now we finished discussion about the bivariate analysis for today. Our second part, that is multivariate. We are gonna be dealing with more than two columns now. Now you might easily guess what we are gonna do. Yes, we are just gonna take another parameter here called z, and it will be multivariate. It's really easy, right? If you take it 3, then there will be a plot of 3. Really easy. Let's see it. Let's use the columns that we already used. Okay. If it takes, make sure to check the doc string. Let's see, there's a hue. So let's apply hue here, and the hue would be a categorical one always. Okay. Then if you give a numerical value and it is ranging too much, then you might get an error. You will be getting an error. Let's see that. So let's put a numerical value. What let's do perch. If it is small, one thing to remember, if it is not ranging too much, okay, like a categorical plot, like in categorical plot you might be having 1 2 3 4 5 10 categories. So like this, if you have only 10 type of values or not so high amount of values, then it will print. But if it is too much, like 1,000 different values, then I think it will give you an error. But in case of our P class, if I'm not wrong, there's only 7 values. So in case of that, it should print. Let's see that. And here you go, and it printed. There's only P class, there's meaning only 3. This is why it is in the legend showing us 3 different colors. So here in this section, it is between 20 to 30 age, and it is ranging to 0 to 20 fair, and this color, this darkest color, indicating it is class 3. Okay. And if you look at this one, it is above 50, the age is close to 40, and it is the lightest one. This is why it is P class 1. Clear? Okay. If you want to see here in the KDE plot, let's see if there's any hue. There is hue. Let's do the same thing. P class. Let's print it. It is really ugly plot, but you get my point. If you can analyze, then you will get something out of it. Clear? Okay. Okay. If you might be wondering anything else, any other parameter, let me give you survived. Let's print it.
Starting narrator, narrator dialog, exiting narrator.
Let's print it. Let's print. And here you go. This is the plot. Okay. Okay, fine. Now for the scatter plot, let's give the hue. Let's give hue as P class. No, let's give the hue as survived. Let's see what that prints out. Easy, right? It is indicating the colors. By doing the colors, it is suggesting us the survived categories, whether it is dead or alive. Clear? The fun thing is that the scatter plot has more parameters. You can do more. If you see the docstring, you can use size, you can use style as well. Let's use those. So you have style. Let's say style equals, let's give what, let's give p class. Let's see, and it printed out. You see, now you have colors, but shape of colors. Now if you want to put size parameters as well, you can do that. You can do that also. Let's see if we can take any categorical ones. mm, let's say class, or alive. Let's put alive. Let's put alive, and here you go. Alive is basically yes or no, and it is giving us the size. If it is yes, then it is small, the size of the dot is small. If it is no, then the size of the dot is large. So this is how you can do multivariate analysis. Let's go to the later parts. Let's see if this takes any parameters. Okay, as I have shown you, the y doesn't uh, sometimes doesn't match the x, and it might give us an error. So let's skip this one. Let's see if this gives any values. Here also takes y, but I don't think it's gonna be print any y. First let's give it a categorical value. What? Who? Okay, it printed. Nice. It printed. Nice. So it is taking p class as a numeric value and who as a categorical value, and it printed. So now you do the analysis yourself. It's really easy right now. Yeah. Okay. You have men, women, and children. You have the p classes here. Fine. And survived, indicating the two columns. If you put that here also, let's see if it prints. If it prints, it prints. If it doesn't, it doesn't. Who? It gave us an error, suggesting that it can't print. If you gave a numerical value here like age, let's see if that prints. Yeah, it printed that as well, and printed really nicely, suggesting all the three classes, the age and also the survived portion. Clear? Okay. Like this, you can do lots of stuffs, guys. Even in the box plot, you can do hue. Even in the box plot, let me do a hue. Let do this sex. Okay, and here you go, the male and female part separate. You have the male portion box plot and the female portion box plot. In the male you have a one outlier ranging really far, in the female as well. Okay, so it is so much easy now, right? We're analyzing three columns at a single time. This is multivariate analysis power. Okay, so guys, I can't show you everything there is, even I don't know everything there is. So just see the doc string and see what you can do. Just play with it, see other plots, see other parameters of the documentation in each plot, and you will discover lots of stuffs. Okay, now one thing to show you more, okay, in our multivariate analysis part. Okay, wait a bit, let me zoom in. Okay, let me do the, okay, it is making, okay, let's get to the point straight away. You can do something called pair plot. Okay, you might be wondering, so much trouble, okay, I have to see lots of plots, lots of stuffs. It would be nicer if I have all the things at one place at one time. We can do that by using something called pair plot. The data would be df, and let's run. It will take a bit of time. Okay, let's wait a little bit. and boom, see all of the possible combinations of the numerical parts. Okay, all are numerical parts. Okay, and you can see different kinds of, I mean, 8 type of plots and 8 type of relationships. Okay, so here I guess there are some 50 plots in a single command. Amazing, right? Yeah, yeah, for sure it's amazing. Now if you're still like I'm lazy, how can I analyze so much? Well, you might be wondering, if it was something like I had done before in the correlation, a single value, you can do that here too. Let's see. You do df, you do df dot core and mention this numeric only, suggesting only the numerical columns, and run it. And here you go. Everything in correlation in mathematical form, nicely printed in one go in a summary. You don't need to see all the graphs and plots to make sure what's the correlation. It's more easy now. Okay, each of the columns are related with each of the every other. Fine, survived itself is survived, so one p class having a negative correlation, and with survived, the survived has negative with p class, negative with age, negative with siblings, I guess it is, positive with purge, positive with fees. So the more fees you gave, the better is the chance of you survived, guys. Okay, okay, there is a loan, etc. Okay, now you might be wondering, it doesn't look appealing. I have that solution for you too. Just create this one and input your oh, first of all we have to declare the, okay, let's copy this thing and just paste it here. You can declare any variable and run, and here you go, a beautiful heat map. It makes your decision even better. The one is the lightest color and indicating all the diagonals are perfectly correlated. Okay, now you might need the numbers as well. I got that too. It is called anode. Make it true and run it again. And 1, 2, and 3. What else do you need, right? Everything you can do. It makes the analysis so easy, right? Everything is one place. Yeah. So guys, this was for our multivariate analysis as well. So let's summarize our session. Today we did bivariate analysis. Here we saw numerical column analysis. We saw categorical column analysis. We saw the mixture of these two analysis. We used previous codes, the codes from the previous lecture session, and introduced a new parameter y to make it bivariate. We saw scatter plots and we saw how we can do lots of stuffs with it. We saw something called correlation and made a mathematical number out of it. Then we also saw the multivariate part as well. In this we just included another parameter in the previous codes, that is z or hue or anything else, right? Then we saw the power of scatter plot. We even introduced, I guess, 5 parameters in one time. Amazing, right? We also saw at one plot getting all of the possible plots by using pair plot. Then if you don't want to have this brutal analysis, you can have the numbers by correlation function again. And if you are a static one, You want something appealing, you can do a heat map on it. So guys, this was about this session. Everything that I've taught you today, all are listed here. And what's for the next session? Something more amazing. What we have done in these 3 sessions, we will be doing in 5 minutes. So stay tuned for the next session and bye bye.